Hello fellow aviators, I am Captain Aziz Azim, Boeing 737 flight instructor and examiner, and I am thrilled to have you here today. We're going to talk about something that is both fascinating and important for all of us in the cockpit. We're talking about the thunderstorms. As pilots, we know that weather can be our best friend or our biggest challenge, and thunderstorms certainly fall into that latter category. Today, we will explore how these incredible storms form, the different types we might encounter, and share some tips on how to navigate around them safely. So, grab a cup of coffee, sit back, and let's embark on this journey together to better understand thunderstorms and enhance our safety in the skies. So please fasten your seatbelts and let's fly through a thunderstorm. A thunderstorm, a violent, short-lived weather disturbance, is always associated with lightning, thunder, dense clouds, heavy rain or hail, and strong gusty winds. In simple words, a thunderstorm forms when warm and moist air rises in a large, swift updraft into the cooler regions of the atmosphere. Thunderstorms can occur in almost every region of the world, so you can meet them everywhere. But remember, due to the cold temperature and dry air, thunderstorms mostly do not form in polar regions and at latitudes higher than 50 degrees north and 50 degrees south. The temperate and tropical regions of the world are the most prone to thunderstorms. Convection remains a serious problem for the aviation community. Severe turbulence above the ground and strong winds with wind shear near the surface are among the hazards caused by the convective activity, which plays a role in many aircraft accidents each year. Thunderstorms require three main gradients, which are the moisture, an unstable atmosphere, and a mechanism to lift the air. The life cycle and development of a thunderstorm is through three main stages, and they are the developing stage, the mature stage, and the dissipating stage. The first stage of the development of a thunderstorm is the developing stage. So in the developing stage, warm moist air rises, forming a cumulus cloud, often looking like a tower. So in the developing stage, there is a strong updraft, and the up-moving clouds can have little to no rain, but occasional lightning may be visible. Once the developing stage is completed, the thunderstorms move to the second stage, which is the mature stage. In the mature stage, precipitation begins to fall, and the updraft now changes to the downdraft. Thunderstorms are very active in the mature stage. In this stage, thunderstorms produce heavy rain, hail, lightning, strong winds, and even tornadoes. The last stage of the life cycle of the thunderstorm is the dissipating stage. In this stage, the updraft is eventually overcome by the downdraft as precipitation increases. Again, there are three types of thunderstorms, and they are the single cell, multi-cell, and supercell thunderstorms. Single cell thunderstorms are also known as ordinary storms. They are short-lived and weak storms with a single updraft and downdraft. They are isolated storms, and the whole life of the storm takes not more than 1 hour. Like other types, single cell storms produce heavy rain, lightning, in gusty winds, but usually do not cause significant damage to the aircraft. Mostly single-cell thunderstorms form in environments with little or no wind shear. So this means that the wind is generally uniform in direction and in speed. Common features include brief periods of the heavy rainfall, lightning, potentially gusty winds, and small hail. Multi-cell thunderstorms are groups of the multiple short-lived thunderstorm cells, and they all move as a single unit. These cells are often arranged in a cluster or line, with each cell at a different stage of its life cycle. Individual cells typically last 30 to 60 minutes, while the entire storm can last for many hours. The cells within a multi-cell storms are in different stages of their life cycle. For example, one cell is in the developing stage, one cell is in the mature stage, and another cell is in the dissipating stage, creating a complex structure. Multi-cell storms can produce severe and damaging winds, large hail, flash flooding, and even tornadoes. Multi-cell thunderstorms can form along linear features like the cold fronts, creating tornadoes. Unlike the multi-cell thunderstorms, these supercell thunderstorms are single-cell storms with a strong rotating updraft, which is also called mesocyclones, so making them capable of producing severe weather, including high winds, large hail, and tornadoes. Supercells have powerful updrafts that can reach speeds exceeding 100 miles per hour or around 160 kilometers per hour. Strong vertical wind shear is a key factor in the development and rotation of the supercell updrafts. Supercell thunderstorms can produce hail, sometimes significantly larger than a golf ball. So they are known for producing intense winds, potentially causing significant damage to the aircraft. Thunderstorms present several hazards to the aircraft, primarily due to the turbulence, lightning strikes, wind shear, and hail, all of which can affect aircraft performance and safety. Pilots generally avoid flying directly through the thunderstorms and instead opting to steer around them using the weather radar information. Thunderstorms can generate strong updrafts and downdrafts, so leading to severe turbulence, which can be uncomfortable for the passengers and potentially damage the aircraft. Thunderstorms can create strong changes in wind speed and direction, and especially near the ground, which can be dangerous during takeoffs and landings. Thunderstorms can produce hail, particularly large ones, that can damage the aircraft, especially the wings and the windshield. In-flight turbulence avoidance is a term which is used by the pilots how to avoid the storms during the flight. The in-flight turbulence avoidance includes the use of onboard aircraft weather radar to detect thunderstorms and assess their severity. Weather reports are another source that pilots can rely on, including the meter or detailed information about the weather conditions, which can be obtained from other sources. ATC or air traffic control can also provide information about thunderstorms and advise the pilots to avoid them. Besides all, pilots can adjust their flight path to steer clear of thunderstorms, consulting air traffic control for alternate routes. Lightning strikes are among the hazards of the thunderstorms, as we know all. Lightning rarely causes significant harm to passengers or aircraft due to advanced safety measures. Aircraft are designed to be Faraday cages. So the Faraday cages channels the lightning currents along the exterior and prevents them from entering the cabin. Now, colleagues, let's talk about the Faraday cage effect. What's that? Based on the Faraday cage effect, the metal fuselage of an airplane acts as a Faraday cage, preventing electrical charges from entering the cabin and protecting the passengers and the crew. Lightning usually strikes a protruding part of the plane, like the nose or the wing tip, and travels along the outer metal surface to an exit point, often leaving minor marks. Aircraft are equipped with lightning-proof systems, shielding sensitive instruments and preventing interference with navigation or communication equipment. Lightning strikes can damage the metallic components like the skin or the structure, or composite components like paint or embedded strips. Aircraft are designed with conductive pads, so static wicks on the trailing edges of the flaps or the trailing edges of the wings or stabilizers to dissipate electrical charges. Engines are also protected to ensure that lightning currents cannot cause sparks in the fuel system. In summary, lightning strikes on commercial aircraft are a safety concern that is effectively managed through engineering design and safety protocols. Let's talk about the wind shear now. Wind shear, which is the change in wind speed and wind direction over a short distance, plays a significant role in the formation and development of the hail. Hail itself is formed by updrafts carrying water droplets into freezing temperatures within the storms. Wind shear can influence the intensity and duration of these updrafts, so ultimately affecting hailstone size and frequency. Strong wind shear can tilt the updraft within a storm, causing it to separate from the rain-cooled outflow. Thunderstorms often present themselves through distinct visual and atmospheric cues. These include darkening skies, dark and towering clouds, flashes of lightning, increased wind, and even a sudden drop in temperature. A general darkening of the sky, so often with a greenish or grayish hue, is a common sign of an approach of the storm. Also look for large billowy clouds that appear dark and are rapidly growing in heights, as these are often associated with the thunderstorms. A sudden and rapid drop in temperature often precedes the arrival of a thunderstorm, as cold air is drawn down from the storm clouds. Best practice for flight planning involve meticulous preparation and route selection. So this includes considering weather, airspace, terrain, and alternative routes, while also utilizing flight planning tools and software for real-time updates and live monitoring. It's important to understand current and forecasted weather conditions along the route, including the temperature, wind, cloud cover, and visibility. Familiarize yourself with airspace regulations, including altitude restrictions, and required communications. Avoid flying too close to terrain, especially in mountainous areas. Utilize flight planning tools to identify terrain hazards. Aircraft should maintain a safe distance of at least 20 nautical miles, which is approximately 37 kilometers from the edges of a thunderstorm. So this distance helps avoid severe turbulence, lightning, hail, and other hazards associated with the thunderstorms. In some cases, pilots may choose to stay even farther away, so that depends on the storm's intensity and the specific flight conditions. Aircraft should ideally pass around the sides of the thunderstorm rather than directly over or under it. The safest approach is to avoid flying near the updrafts and downdrafts associated with the thunderstorm. The air traffic control, or ATC, plays a crucial role in helping pilots avoid thunderstorms through several means. Air traffic controls provides real-time weather updates, including information about the thunderstorms, the turbulence, and severe weather conditions. This can include radar data and visual weather maps. Air traffic control can suggest alternative flight paths to help the pilots steer clear of the storms. This might involve rerouting the flights or providing vectors to avoid areas of the severe weather. Air traffic control ensures that aircraft are safely separated from thunderstorms by maintaining appropriate distances and altitudes, minimizing the risk of the encountering turbulence or adverse weather conditions. Air traffic control often works closely with the meteorologists, who can offer insights about the storm development and the storm's movement, helping to guide the pilots more effectively. Air traffic controls collects and disseminates pilot reports about the weather conditions, which can include the first-hand accounts of the thunderstorms, helping other pilots make informed decisions. Air traffic control issues alerts and warnings about the severe weather phenomena, including the thunderstorm activity, allowing pilots to take proactive measures. By providing this support, air traffic control enhances flight safety and helps pilots navigate around potentially hazardous weather conditions. Thank you all for your attention today, as we have explored the critical topic of thunderstorms and their impact on aviation. We have learned about the various hazards these storms present, from the turbulence and lightning to hail and wind shear. As pilots, our primary responsibility is to ensure the safety of our aircraft and passengers by understanding the nature of the thunderstorms, maintaining safe distances, and utilizing the resources available to us, like the invaluable support from the air traffic control. We can navigate these challenges effectively. I encourage each of you to stay informed about the weather patterns and to always prioritize safety in your flight planning and operations. Remember, being proactive and prepared is key to ensuring the safe skies.